Okay, this is McGraw-Hill Chapter 5, Section 3, Addition and Subtraction of Rational Expressions. Make sure you understand, I've already gone over this in class, is that we treat rational expressions just like we do regular fractions. Remember, rational expressions are nothing more than fractions with variables. So if we want to add or subtract two rational expressions, we've got to get a least common denominator. Here we have 7b, here we have b squared, so we got to keep a 7, we keep the b squared, so our least common denominator is 7b squared. In order to get this to have 7b squared, we've got to multiply by b on the bottom. When I multiply the bottom by, I got to multiply the top by b as well. Here I got to multiply by 7 to get 7b squared, so I got to multiply the top by the same thing. So this, b over b times 3 over 7b gives me 3b over 7b squared. 4 over b squared times 7 over 7 gives me 28 over 7b squared. So I end up with my final answer of 3b plus 28 over 7b squared. Same principle as adding fractions that are numbers. You just got to get the least common denominator. Here's example 6 on page 442. Problem says 3t minus 2 over t squared plus 4t minus 12 minus 5 over 2t plus 12. Well, in order to get the least common denominator of a rational expression, you have to be able to factor. It's a very important process. So the t squared plus 4t minus 12 is a trinomial. Because it's a trinomial, we can factor this by doing 6 minus 2. Because the last term's a minus, we got opposite signs in our parentheses. And it becomes t plus 6 times t minus 2. My outside times my outside gives me a minus 2t. Inside gives me a 6t. 6t minus 2t is 4t. Works. Here we factor by greatest common factor by factoring out a 2. So we get 2 times t minus 6. And if we look at our different factors, we have a 2. We have t plus 6, t minus 2. So our least common denominator is 2 times t plus 6 times t minus 2. If any of these, we don't combine these. It's the single exponential power, the highest exponential power from a single term. So this is t plus 6 to the first power. This is t plus 6 to the first power. We don't combine them. We can only use what they are. Now, if this had been t plus 6 squared, we'd have done t plus 6 squared. So in order to get this to be 2 times t plus 6 times t minus 2, we've got to multiply by 2 over 2. In order to get this to be 2 times t plus 6 times t minus 2, we've got to multiply by t minus 2. So this gives me 6t minus 4. This gives me minus 5t plus 10. All over 2 times t plus 6 times t minus 2. Combine my like terms here. I get t plus 6 over 2 times t plus 6 times t minus 2. I have t plus 6 top and bottom, so they become 1. So my final answer is 1 over 2 times t minus 2. Make sure you understand that, and hopefully I've explained it well in class. You don't combine factors. You're taking the highest exponential power of any factor in a single term. So this is t plus 6 to the first power, this is t plus 6 to the first power, so we keep t plus 6 to the first power. Had one of these been to a higher power, we'd have taken it. Here's example 7 on page 442. This has 3 rational expressions being added and subtracted. So we have 2 over x plus x over x plus 3 minus 3x plus 18 over x squared plus 3x. We've got to factor. These are already in factored form. We've got to factor this. This factors into x times x plus 3. So when we look at our different factors, we only have 2 factors, x and x plus 3. So x times x plus 3 is our least common denominator. We have to multiply this by x plus 3 to get x times x plus 3 on the bottom. Multiply top and bottom by it. We have to multiply this by x on the bottom to get x times x plus 3, top and bottom. Multiplying this, we get 2x plus 6. Here we get x squared. Distribute this minus, we get minus 3x minus 18 all over x times x plus 3. If we combine like terms, we get x squared minus x minus 12 over x times x plus 3. This is a trinomial that can be factored. Factors into x plus 3 times x minus 4. We have x plus 3 on the top and the bottom, so they become 1. So our final answer is x minus 4 over x. Here's example 8, page 443. It's 6 over w minus 4 over negative w. Remember we talked about fractions. When one of the top or bottom is negative, the whole thing is negative. So this is a double negative, which makes it positive. So we have 6 over w plus 4 over w. We have the same denominator, so we don't have to do anything. So it becomes 10 over w. So remember, this is another time when you got to understand your fraction rules. You know, as long as one's positive, one's negative, doesn't matter top or bottom, the whole thing's negative. So if I'm subtracting a negative, I have my double negative rule, makes it positive. Have the same denominator in both rational expressions. So all I got to do is add my numerators and I'm done.